Hello and welcome to 2.5. This section is all about graphing and transformations, your stretches when you rotate over the X or you flip over the Y, your domain and your range. So you should have 2.5 in front of you. Look over your objectives and let's get moving. All right, so we're going to recognize common graphs. So these are basically your parent graphs. Do you know what they are? Is what this wants to know. And we have a bunch of them we need to remember. Your vertical shifts, so when you move left and right. Horizontal, when do you move up and down. Reflections, when do you flip over the x-axis. Vertical stretching and shrinking to graph functions. Your horizontal shrinking and stretching. And then your sequence of transformations. So here we go. Some of these I do a little differently because I think they're easier. All right, if you have Desmos at home, or you can actually go onto your computer and search Desmos, and you will get a free graphing calculator. I would like you to do that. So search Desmos, open it up, and type these functions in and graph them. I would like you to recognize what's the same, what's the different, what your domain and range is, where it's increasing, decreasing, and if it's even or odd. So please pause the video and get those done. All right, I hope you've noticed a few things about your parent graphs. They all go through 0, 0, the origin, because none of them have moved, is why that is. All of them also go through the point 1, 1, because any value of x, no matter what you do to 1, it's always 1, which is very helpful in some of the things that we do. Now, let's look at this one. Your line, so you went, I'm hoping your y-intercept was 0, your slope was 1 over 1, and you drew a line. Your domain, so remember that's your x values. So where there's x values here in this one, it goes on forever this way and this way. So it's negative infinity is where it starts and it ends at positive infinity. Range is the same. So now you're looking at y. It starts at negative infinity and goes to positive infinity. Increasing and decreasing, this line right here is always increasing. There's no decreasing section, so that's from negative infinity to infinity. I should have put it increasing. Even or odd, remember we plug in a negative x to the function. If we get the opposite, it's odd. We get the same, it's even. Well, negative x plugged into x is negative x, which means it's opposite, so it is odd. Your x squared. Things you should have noticed. It starts at 0, 0. It goes over 1, up 1, to the left and to the right. And if you wanted to, you could do 2, 4 also. When it's here, it starts at 0, 0 again. If you look at the range, it goes on forever in this direction. So at some point, these values will have answers. Our x values will have numbers. So it's negative infinity to infinity. And when you look at the range, though, if you look at the y, there are no values where it's negative. So this range starts here at the turning point or the vertex. So it goes from 0 to infinity. On this half of the graph, so from you're reading from left to right now. So from negative infinity to 0, this graph is decreasing. And from 0 to positive infinity, this graph is increasing. Even or odd, we plug in our negative x. Well, the square of negative x squared is x squared, so it's identical to our original, which means it is even. X cubed, again, negative infinity to infinity for both the range and the domain. Again, increasing the entire time. It never ever decreases. Should have put my eye again, sorry about that. Plug in our negative x. Well, negative x cubed is negative x cubed, exactly opposite, so it is odd. If you did not get those right, pause and redo the bottom ones. Okay, your absolute value was your v. It's negative infinity to infinity for your domain. Your range, again, has nothing on the negative, so it starts at the 0 to infinity. This one here is decreasing from negative infinity to 0, and then from 0 to infinity, it is increasing. Let's plug in our negative x. Well, the absolute value of negative x is x. These are identical, so it is even. This one was a little tricky. This is just a square root. There's nothing in front, which means it's only the positive section of this. So when you do your square root, so like square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, correct? So you drew in your line. Now your domain starts at 0 because there's nothing on this side. So it's 0 to infinity. Your range also starts at 0 and goes up forever. So it's 0 to infinity. It is also increasing from 0 to infinity. Plug in a negative x. Well, I cannot take the square root of a negative x, so this is neither. Now, do this one again. Domain, negative infinity, infinity. Range, the same. Always increasing. Do the cube root of the negative x, and you should have gotten odd. Now, we're going to move all these things. Those parent graphs, I expect you to know. So if you don't, practice them, study them. Okay, I would like you to actually first plug this into Desmos and see what it does to your graph. So make sure you have the x squared, your parent graph, on. So you should have this on your screen, your x squared in your Desmos. Okay, now underneath, put x squared plus 3. And what did it do to your graph? As you should see, it's going to move that entire graph up 3. And same step. So this one went up 1 over 1. This one here should also go up 1 over 1 to the left and to the right. I really only care about the 3 dots is what I'm going to grade. So now when you do this, you're looking at your red because this is your transformation. And anything behind the x moves it up or down. So this here moves it up or down. Since it's positive, it moved it up. So like this one here is negative, so it's going to move it down. All right, when you look at your domain is your x, still negative infinity to infinity. Your range starts at the vertex. So your range starts at 3 and goes to infinity. Increasing and decreasing, again, the same. Goes from negative infinity to 0. That's where it's increasing, or I'm sorry, decreasing. From negative infinity to 0, it's increasing from 0 to infinity. And I just wrote that wrong. I don't know if I can erase that somehow. That it's supposed to be a parentheses. There it goes. All right. And even or odd. So now let's plug in our negative x. So f of negative x is equal to negative x squared plus 3, which equals x squared plus 3. Therefore, it is identical, so it is even. All right, pause and try your 2. Okay, I hope you did well. The blue are your parent graphs from above, and the red are your transformation. So the negative 2 moved this entire graph down 2. The positive 1 moved your absolute value up 1. Notice your stretches are still the same. So this guy starts at 1 here, goes up 1, right 1. This one goes down 1, left 1. This one should do the same. Up 1, right 1, down 1, left 1. Those are the points I'm going to be looking for. All right, domain and range are identical, negative infinity to infinity, always increasing, negative infinity to infinity. Plugged in your negative x, you get negative x, I forgot my cube, minus 2, which is not exactly opposite or the same as this, so it is neither an even or an odd function. Do this one, negative infinity for domain. This one starts at 1, your vertex, from 1 to infinity, well, not actually a vertex, to infinity. Domain are decreasing from negative infinity to 0, and then it starts increasing from 0 to infinity. Plug in your negative x. It is identical to your original, so therefore it is even. All right, so that was up and down. Now we're going to move left to right, or your horizontal shifts. So now once inside are attached with the x, that's moving left to right. To figure out which direction it moves, you take this and you set it equal to 0. So we say x minus 1 equals 0. That means x is going to move right 1. Over here, we'll say x plus 2, guess I don't need the parentheses, equals 0, which means x is going to move left 2. You can do that one on your own. All right, let's do this one together. Square root. So we know the parent graph starts at 0, 1, 4, 2. And there's my parent. I should have drawn that in blue. We'll go the other direction now. Now, negative 1 means it's going to move to the right 1. So every point moves right 1. And there is my shift. Domain, now it starts at 1. So it's 1 to infinity. Range still starts at 0, 0 to infinity. It's always increasing, but it starts at 1 because it doesn't have a value before 1. So 1 to infinity, plug in your negative x. So now we want to know f of negative x. So I'm going to do the square root of negative x minus 1. And that is not exactly opposite or exactly the same. So therefore it is neither. Okay, pause and try yours. Okay, I hope you did well. You should have had the shift of this graph to the left, the shift of this one down 1. Then your domain and ranges are here and plugging in your negative x's. Nothing different than what we've been doing. Okay, let's move on. All right, now we've taken and we've shifted left and right. Now we're going to do about a reflection. So when we do this, and this is over the x-axis because it's here, so let's show you what's happening. So we know that the original square root of x graph looks like so, correct? Now the negative 1 moves it to the right 1. I'm going to do this in 3 steps. So this moves this entire graph to the right 1, like so, if it will drop. And then this negative changes all my values from a positive value to a negative value. So now it reflects over the x-axis, like so. This is your final graph. So this is your parent, this is your first transformation, and this is your final. Okay, pause and try yours. Okay, you should have first drawn your cube graph, which was this one. All right, the +2 meant the entire graph moves left 2 and flips. So we can do that in one step. We can go left 2. So we're going to go over here. We're going to put our center of our graph, maybe. Now, instead of going up 1, right 1, I'm going to go down 1, left 1. And then instead of going left 1, down 1, I'm going to go left 1, up 1. And then my new graph looks like so. That's your transformation. This one here, you should have had a parent graph of your absolute value. There's nothing attached with the x, so it doesn't move left or right. It just reflects over the x. So instead of going up 1, left and right 1, you go down 1, left and right 1. And there is your new parent. Okay, I hope you did well. Okay, now we're going to do over the y-axis. It's a little bit different. I usually don't think of them this way, but that's okay. We can. Okay, so x squared, let's do these. We have a parent graph, and you should know your parabola, 0, 0, 1, 1, negative 1, 1, maybe. All right, +3 means it's going to move up 3. So now we go up 3, but now it's a negative x. So this up 3 is going to reflect it over here. If I can get it to drop, and it is not liking these parabolas for some reason. Okay, now the negative x means I'm going to reflect it over the y. So what this is going to do, so now when I plug in my negative x value, I'm actually going to go down. Okay, here, let's show you if I can show you. Okay, but this is showing you, and I don't know if you can see it real well. If I plug in the -2 for my x, I get 7, right? Well, if I plug in the 2, I also get 7. Technically, these things are reflecting over here. It's moving them over this direction, but the points are identical on each side because a parabola is symmetrical. So you cannot see the reflection because this technically is identical to x squared plus 3. There's no difference. All right, let's do the cube root and see if this one's a little bit better. So now we know our cube root goes this way and this way, right? I missed my 1, 1. Hopefully you draw better. So that's my parent, my cube root. -2 means it's going to move down 2. This negative x means it's going to rotate around the or the y-axis. So let's show you. It's the same as doing this. I always cheat on these and I make them rotate over the x because I think it's easier, but we will try this. So we've got the cube root of negative x. We're going to do that one first, and then I'm going to move the thing down too. So the cube root of negative x, so if we do this, and we do the cube root of negative x. Whoops. If I could write, that would help out, huh? All right, so let's look here. If we plug in -1 into my cube root of negative x, we're going to worry about this last. So we go through, we plug it in, and we get -1 is 1. So well, -1 is 1. If it will go. There we go. We'll put an x. We get 0 is 0 again. And now when we plug in 1, we get -1 right here. All right. When you look at that, this value here is now here, and this value here is now here. It has reflected over the y. Technically, it's also reflected over the x. So now we go through like so, and we draw on our graph. Now I must move the entire thing down 2. So now I take that cube root and move it down 2, and we are here. And there is your new graph. Okay, the reason I don't do this is I change these into reflections over the x every time, if I can, because this here is identical to negative cube root of x minus 2. All right, and it's now easier for me to see, but you can do it your way also, or this way also. So now I'm taking my cube root of x, I'm reflecting it over the x, and I'm moving it down 2. It is the exact same thing, but you can do whichever method you like best. Okay, absolute value of negative x plus 1. All right, technically that reflects over the y, but if you look at it, so this is your parent, if it will draw. Okay, when I take the absolute value of negative x, I get the x value, right? So now this thing is reflecting back and forth. So when I do this plus 1, just moves this thing up 1. So now your new graph is here. And again, you are correct. I cheat. I say, hey, that is the same thing as x plus 1. And I graph it. And I'm done. So if you have questions, let me know. And do it whichever method you like best. You can always use the table if you're getting confused. Okay, what do these 2 1/2 do? So when there's a number in front, this is a stretch or a compression. So we know x squared looks like so, right? This is my parent graph. So now I'm going to, okay, after you plug in your parent graph here, the blue one, you do the 2x squared. So you multiply every y value by 2, and you get the new graph. If you look, this first point right here acts like a slope, but only on the first point. So when we go here, this here, I can treat this as 2 over 1, and it goes up 2 over 1, up to left 1, and I can draw in my new graph. It will not do 2 over 1 again because it's not truly a slope, because it only works when you square 1, because 1 is 1. Now let's look over here. We have our parent graph again, our green one. Now if we multiply every y value by a half, we end up at 0, 0, we end up at a half, and 2 ends up at 4, right? Well, look at your stretch. This is 1/2. So if I go from here up half over 1, I treat this sort of like a slope. I go up half over 1, and I draw in my new graph, and I have my compression. It only works when x equals 1. because when you look at 2, I don't go up a half again over 1. I go up 1.5 because this is a squared. So if I only graph the first 3 points, I will get my stretch or my compression. If you want to do more, then it's the table. Okay, now let's go down here. Again, but this time the squared is on the outside. So instead of doing that, I'm actually going to do it. So I got 4x squared when I go through, correct? Now I'm going to go 0, 0. I'm going to go up 4 over 1 and 1. It will not work again, only on the 0, only on the 1. But then I can draw in my stretch. This one here is kind of cheating. I was hoping I messed with you. This is the exact same above because the square is not in the outside. All right, so be careful where your exponents are. All right, let's continue down. I'd like you to pause and try these. All right, if you look here, your parent graph was the black one, your cube. You're going to move left 2. You're going to move down 1. So from 0, 0, I go left 2, down 1 right here. Now I treat this as a stretch, or it's a reflection also, right? So from this point, I go down 3, left 1, because generally I went up 1, right 1, right? So this just means I go down 3, right 1. So I go down 3, right 1 to here. Here I would go down 1, left 1. So now I'm going to go over 1, up 3 from this point. And I draw in my new compression, or my new rotation and stretch, or reflection, sorry. This one here, you should have moved left 3, up 2. So I go left 3, up 2. This is where I start. Now I graph my 4, or my stretch, which is 4 over 1. I go 4 over 1 both directions and draw in my new absolute value. I hope you did a great job. Take every value of x and multiply it by 2. So